Okay, so we want to factor this completely. We can see that it is a degree 3 right now, which means it's going to have 3 solutions, and which means it's going to probably have 3 factors. Now, one of them might be repeated, so I might have a factor with a squared on it, but I should be able to see that I have 3 answers at the end. I'm not done until I have all 3 answers. If we're giving you that x equals 3 is one of the roots, that means that the factor x plus 3 created that root. So we already know one of the 3 factors here. But I don't know what the other 2 are. And if I know that this is a factor, that means that it has to go into this polynomial evenly. So if I divide them, then I'll be able to take this polynomial that's currently a degree 3, and if I divide x cubed by an x, I'll take it down to an x squared. And then whatever I have left, I'll be able to factor again, and I'll be able to see what my remaining 2 factors are. So you can think about this as like, let's say the number 12, let's do the number 36, is really the number 3 times, actually let's do 24. So 24 is really 3 times 4, which would be 12, right, times 2. So you can see that the number 24 is made up of these 3 factors. Well, if I told you that 3 was one factor, you could divide 24 by 3, and you would get 8. And then you could see, oh, well, the 8 splits into 4 and 2. So we're going to do the same thing here, but with polynomials. So if I know that this is one factor, I'm going to use synthetic division because I like it better than long division, but you could use long division if you prefer. So drop down the 2, multiply here, and add, multiply, and add, multiply, and add. Now I should not be surprised that this is 0. I knew that negative 3 was one root, so I knew that it would go in evenly. And that's why I wanted to use it, because now what I have left is I have this is my lone term without an x. So this is going to have x with it, and this is going to be x squared. So the polynomial that's left looks like this. So I know that this is one of my factors. So if I did x plus 3 times this quotient that I got when I did the division, I would get this original polynomial. So this is one of my factors, and all I need to do is break this apart into its other 2 factors, much like we would have broken the 8 into 4 and 2. So now I just have to factor this. So we're just going to use our normal factoring techniques. This is a trinomial. I'm just bringing this down. This is a trinomial. So 2x and x will give me 2x squared. And then I could use either 4 and 1 or 2 and 2 to get 4. But since this is a 7, I'm thinking I'm going to put a 4, and I'm going to need it to be out here so that it will multiply with the 2 to get 8x. And then I'll put 1 here. Now if I want to end up with a negative 7x, my 8 is going to need to be negative, and my 1 is going to need to be positive. But you can check this real quickly to make sure that it is what you need it to be. If you do all of your 4 things right here, you can see that that will give you the negative 7. So this is correct. So the complete factorization is this. Notice that we have all 3 of our factors like we said that we would need at the beginning.